All right, so I want to start with an introduction on SEM. So again, SEM is scanning electron microscope. So before we get started, I want you to think about um, what factors make the SEM the most commonly used type of electron microscope. So basically I want to see how much you know about SEM, and if you don't know anything, that's fine. Just write something down. But in the quiz, if you can uh, list some factors that you think make SEM the most widely used type of EM. So go ahead and go to the quiz, fill out what you think, and then come back here after you've done that, unpause, and I'll list some of the reasons that I've chose to talk about. All right, so now that you're back, let's talk about some of these factors, why it's the most commonly used type of EM. All right, so here's three that I've chosen, and again, it doesn't just have to be these three. If you wrote something different, that doesn't mean it's wrong or right. But what the three that I chose are three that come up quite a bit. So the first one is 3D appearance of images. So if you've ever seen SEM images, you might have known this, seen some of this, where it actually looks like it's a 3D picture, right? And so this is produced because in SEM, we have a large depth of field, right? So that was, if you remember from optical microscopy, all these different heights being in focus at once, right? So this gives us powerful information about topography, right? Different changes, and it means that we can see a lot of different surfaces on the sample at once. So this is really powerful, right? This tells us a lot of information, and therefore it's going to be good for things like fracture surfaces and things that have a lot of topography. So that's one. The other one is, of the EMs, it's probably the easiest to operate and maintain, and it's also relatively cheap compared to the others. So you're probably not going to go home and buy one of these and put it in your garage, but compared to the others, and most institutions, can afford to have this and maintain it really easily. They are getting more and more expensive, but that's because the functionality is becoming more and more expensive. You can also get more entry level, like sort of tabletop versions that do same things that machines of several years ago might have only been able to do. So very powerful, easy to operate and maintain. And lastly, the SEM, which is a microscope used for imaging, can also be coupled with other instruments like the EDS, which we just talked about in the previous module, so I wanted to bring it up here. And so when coupled with things like EDS, it can give you chemical information. So what elements are present and what quantities. So the power of this technique is very useful, and that's what makes it very powerful and widely used among the types of EM. So we'll also talk about TEM in the next section, and I'll again kind of start with what separates TEM and SEM from the other types as well. All right, so let's start with kind of a comparison between SEM, which we haven't talked about, and components of an optical microscope, which we talked about quite a bit at the beginning of the semester. So this is a typical compound light microscope that you've seen from earlier in the semester. And then here is a sort of a schematic of an SEM. So there's quite a few different components compared to a light microscope, but a lot of the things are the same. So first of all, we need a illumination source, just like we did here in a light microscope. Here, it's an electron gun. So similar, but different. So here we have high energy electrons that we're using as opposed to visible light radiation. All right. Secondly, you'll notice that this says condenser, objective. So these lenses are not what we think of as optical lenses because we're not dealing with light, we're dealing with electrons. So they are lenses, But what they do is they focus electrons. So what we use for that is actually electromagnetic coils. So again, they're called lenses and they have the same function, but since we're dealing with different radiation or different particle type, then the structure of the lens is going to be quite a bit different. So that's the main thing. But these have the same function. These condenser and objective lenses have the same function. They focus and they magnify the image just like the lenses in a light microscope. But again, we use electromagnetic lenses as opposed to glass lenses. So similar, but different. All right. Another portion, which we see kind of listed, it's a little hard to see on this diagram, but referred to as scan coils near the objective lens, is this is the part that is most different than light microscope, because in this type of microscope, what we're doing is we're creating a very fine beam and then we're scanning it across the surface to prepare a much larger image. Whereas a light microscope looks at the whole image at once. So whole spot size is illuminated at once, whereas in SEM, the beam is rastered, moved, scanned across the surface to give a much larger image than the single beam. So we need these scan coils. So this part is much different. But again, it gives the scanning part of the scanning electron microscope. So this is kind of the defining feature of the scanning electron microscope and the part that you'll never find on this light microscope over here. All right. And so lastly, here we have a detector of some sort, which is going to collect the electrons that are generated, right? And so in the case of the light over here, that's done with our eyepiece and so forth, or the camera. Here it's a little different because we're dealing with electrons and we can't see those electrons, so they have to be detected in order to generate an image on the screen. So again, this is a part that looks quite a bit different. So again, just showing you some of the similarities and differences between these two components, because then we're going to go in a little bit more detail and talk about these various components for the SEM in the next section.